Hey guys, Math 1, we are starting Chapter 4 today. As I sit here today, we are about to go into our last day of hybrid and go into Thanksgiving and then start remote learning again, so I hope that goes well for everybody. Please email me if you have questions or see how it goes. So, we are starting Chapter 4, and this is going to be a really interesting one today, I think, because today we are going to learn how to use this guy better. But before we can do that, we got to go over a little bit of vocabulary. Chapter 4 starts out talking about the relationship between two variables when you graph them. I know it doesn't sound very interesting, but it really is. You'll like it. I think you'll like the example today. It is good math. So here we go. So first we need this vocabulary. It says in the first section of Chapter 4, we dive a little bit deeper into graphs and scatter plots of data. And this is really the important thing because data is often not perfect. Often it is a scatter plot and you have to interpret it. And that's kind of what we're going to do today. And we are going to learn how to use technology to do that eventually. To help us learn about the relationship. That's a good word. I like that word. The relationship between X and Y. And today I'm going to point out the relationship between two things, perhaps. So here we go. So when you describe a graph, there are four different things that we want to use when we describe a graph, and I have them listed here. So number one is the form. And for us at this moment, the form will mean one of two things. It will either be linear or it will be nonlinear. Now, there are many different types of nonlinear graphs, but all we care about right now is linear or nonlinear, right? A linear graph might look like this. That'd be a scatter plot that appears to be linear, whereas a nonlinear graph, it might look like this. So it kind of has some curve to it. All right, the next thing we care about is the direction. Let's change color for that one. All right, so when we talk about what a graph looks like, we want to talk about the direction, which is similar to slope. And it really just means, does the data have a positive or negative direction? And that looks just like slope. So perhaps, I'll draw two of these. Perhaps your data looks like this. Or perhaps the scatter plot maybe looks like that, right? It says here, as X goes up, Y goes down. So that would be this one over here, right? As the X values go to the right, the Y values are going down. That is a negative direction. And as X values go up, as X gets bigger, Y also gets bigger. That is a positive direction or a positive slope. Okay, I think that's pretty obvious to everybody. All right, the next one is strength. This is the amount of scatter away from the best fit line. And I'm going to do some examples of this in a second after I do outliers. But there might be four ways we talk about this. If most data points are very close to the line, that would be a strong relationship. If they're a little more spread, then we might say that's a moderate relationship. Even more spread out might be a weak relationship. Or basically the data points make a cloud. That would be no relationship. And the last thing we have is outliers. Outliers are points that don't seem to fit the rest of the pattern. And I'll show you an example of that right here. So right here, I'm going to do 4 graphs. Let me make kind of 4 graphs here, not too big. And let me go through these. So the first one, maybe the first one looks something like this. And if I were to draw a best fit line through that, you know, a best fit line might look something like this. And I definitely think those red dots, they probably look linear, right? They probably looks like as X goes up, Y goes up, and it's about the same amount all the time. I think it looks linear. So if I was going to describe this, I need to use all 4 of these things. There's number 3 and there's number 4. I need to use all 4 of these things. So I might say this has a positive, you know, I might go moderate. I should have said that first probably. A moderate, positive, linear relationship with no outliers. That is what I would call that one. Moderate because the dots are a little bit spread out, but not much. And I think that's linear. And there are no outliers, and it's definitely positive because it goes up, right? The second one. Let's draw the second one so it looks like this. If I were to draw a best fit line for that, it might look like this. All right, so I think I would call that one a strong, maybe we draw a line there, a strong, negative, linear, and I like the word relationship in there, relationship with one outlier. Right? There's certainly an outlier sitting there off the line. And there's many different reasons there might be an outlier. I mean, it could be an error in collecting the data somehow, or it could just be that, you know, there's always one that's different than the rest for one reason or another. So there you go. Negative, obviously, very strong because all the dots practically make a line. So very strong, not much scatter away from the line. Okay, and we get to our third one. And maybe in our third one, we have something like this. And so this one, to me, if I tried to draw a best fit line, I don't think it would be a line. I think it would be more of a curve like that. So I think that's pretty strong as well. I might call this one a strong, nonlinear. Let's see. Oop, I forgot positive. Positive. A positive, strong, nonlinear relationship with no outliers. You agree with that? So you see, basically, I'm using all 4 of these words each time, all 4 of these concepts when I describe my graph. And just for the heck of it, I thought I'd show you maybe what a cloud looks like. So maybe if your data is just all over the board, there is no relationship. That would kind of be a cloud here. It seems like the X and the Y have no relationship with each other whatsoever. All right, so that is the first thing. You've learned some new vocabulary. Next, we are going to do an example here, and I'm telling you right now, you do not have room on your paper to do this example. you have a little bit of room. Maybe if you wrote exceptionally small, you could, but it might take another sheet of notebook paper or something. I'm not sure. So here we go. We want to find the equation for the line of best fit. Now, this is something we've done, but I want you to stay with me on this. I'm going to add some new things in here. So here we go. I'm going to move this up so I have some room. And I'm going to draw a graph over here. So my graph is going to look something like this. And I've decided that my x-axis is going to measure minutes since I ran over a nail. Minutes since I ran over a nail. I was driving my car along at one point and I got a flat tire, and it's because I ran over this nail, and I decided I'd create this little graph about it. And over here, the y is going to calculate my tire pressure. That is calculated in what's called PSI. PSI is pounds per square inch. And the tires on my car, when they're full, have 44 pounds per square inch. So over here, I am going to count by tens. And down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I'm going to count by ones. You get the idea, hopefully. All right. So I made this little table where my x, of course, is minutes, all right? And my y is my PSI, my pounds per square inch. And I know that after 0 minutes, I had 44 pounds per square inch in my tire. The tire was full. And then after 2 minutes, I was 41.1. And then after 5 minutes, my tire was down to 39.8. And then after 7 minutes, I was at 38.8. And after 12 minutes, my tire was down to 34.1. So my tire is slowly losing pressure, isn't it? It's a little bit sad. So I'm going to graph these ordered pairs on the graph. So 0.44 might be about right here. A little bit between, right? This is 40 and this is 50. And I'm a little bit less than halfway. Then when I get to 2, I'm just a little bit over 40, so maybe like right there. Then when I get to 5, I'm a little bit under 40, so maybe about right there. Then when I get to 7, I'm at about 39. Still a little bit under 40, but not too much down from 38.8. And then when I get to 12, I'm at 34, so halfway, a little bit less than halfway between 30 and 40. Maybe about right there. So those points do not look like they line up exactly in a straight line, but they're pretty close. I'd call that pretty linear. If I was going to draw a line of best fit, it might look something like that. That's pretty good. Pretty good. It's a pretty straight line, too. Okay, so here's what we're going to do. The first thing, we're going to describe the graph using our 4 words. I don't know what you guys think, but I think that is a pretty strong relationship because there is not much scatter away from the line. I'd say it's definitely negative because it's going down, right? As the minutes go up, the tire pressure is going down. I'd say it's linear. So it's a strong negative linear relationship, and I'd say no outliers, right? All right, I have described the graph. The next thing I want to do is I want to come up with an equation for the best fit line. We've done this. I don't really care if you write this down as I do it, but I'd like you to watch and listen because I'm going to say a few things that'll be good. All right, so if I want an equation for the best fit line, the first thing I need is I need a couple points to use. And I don't like to use points that are already in my table. So I'm going to pick like right here. And I like to spread them out. So I'm going to go out to about 10 and maybe pick like right there. And I think that first point is at about 143 maybe. And I think that second point is at about, well, it's at 10. And maybe about 1035. We'll go 1035. And now I can come up with the equation for my line, right? First, I would get the slope. The slope would be y minus y, 43 minus 35 over 1 minus 10. It'd be negative 8/9, which if I rounded that, be about negative 0.9. Negative 0.8888, repeating actually. But I'm going to round to the nearest tenth. And then I need the y-intercept. Now you guys, I know it looks like the y-intercept is right here at 44, but sometimes your best fit line does not go directly through the points on the table. So you need to calculate the y-intercept. And if I was going to calculate it, I'll probably take this first point and use it to calculate it by saying y equals my slope times x plus b. And that would be 43.9 when I calculated it. So my equation for my best fit line is y equals negative 0.9x plus 43.9. And I have my equation for my best fit line. Now, do you know what the numbers in that equation mean? We did this, I think, in chapter 2. Can't remember now. What does the negative 0.9 mean in this equation? One of the things I want to be able to do is interpret the slope in the context of the problem. Right? What does that negative 0.9 mean in the context of the problem? Well, here's what it means. It means that the y value goes down 0.9 for each x value. Or it means the PSI goes down 0.9 pounds per square inch each minute. All right? The tire pressure, I wish I'd put that here instead. The tire pressure, that's really what I'm measuring, the tire pressure. The tire pressure goes down 0.9 pounds per square inch each minute. That is what the slope means. And of course, the y-intercept means, the 43.9 means my tire pressure before I hit the nail was 43.9 pounds per square inch. All right. So the next thing, and now we're going to start talking technology. Okay, I know this is a long video. It gets to the good stuff right now. We're going to talk the R value. This is where we start talking technology. What does the R value actually mean? Well, the R value measures strength. It measures the strength, and your calculator will do this for you. It measures how much scatter there is. And for right now, let me tell you that the R value is always between 1 and negative 1. It is always between 1 and negative 1. Negative when the slope is negative, and positive when the slope is positive. And the closer to 1, the stronger the relationship. So if the R value is like 0.3, not very strong. But if it was 0.9, strong. Or in my case, it'd be negative. So maybe negative 0.9, strong. All right, let's turn our notes over to the back and let's see some cool stuff. So you're going to need your calculator now. And I'm going to spend the next 10 minutes or so showing you stuff on your calculator. And the first thing I'm going to show you, I don't really have listed in the notes. I wish I had done this, but I did not. So there is a key button I'd like you to see first, and it is the Y equals button. The Y equals button is in the upper left-hand corner, and if you hit it, there should be nothing there. If there is something there, you should clear it so there is nothing there. And I want you to see this cool thing. So this is where you can actually type an equation into your calculator. And you've already started the equation Y equals. And you'll need one more button for this. And the other button you need is the button that says xt theta n. This is next to the green button. This button is next to the green button at the top of your calculator. It's right up here next to the green button. And this is your variable. It's your variable x. When you type an equation into your calculator, that is what you hit when you want to put in the x. So the first thing we're actually going to do is we're going to hit Y equals, and we're going to type in 2x minus 3. So I'm typing it in, and it should look like that. Y equals 2x minus 3. And now the cool thing, we're going to go to the right-hand side at the top, and we're going to hit graph. And your calculator should graph the line just like that. Right? That line has a y-intercept of -3. See how mine goes through -3? And it's got a slope of 2, up 2, right 1, up 2, right 1. You have just graphed your first line on your calculator. If your graph does not look like mine, because somebody has messed around with your calculator or something, that's fine. Try hitting the top middle button that says zoom, and then this table comes up. Now hit the number 6 for standard. And that will take you to the standard graph that I have. That standard graph is where the x-axis goes from -10 to +10, and the y-axis goes from +10 to, or -10 to +10. All right, let's go back to Y equals, and let's hit clear to clear that equation, and let's learn some cool stuff here. All right, so your calculator will calculate, well, we can put data into your calculator. And I think I forgot to say something back here. Sometimes you'll see this best fit line is called the least squares residual line, or for short, the LSRL. I don't want to talk about what that is, but it's basically how we calculate the exact best fit line. And you don't have to know how to do that, but that's what it's called when you actually calculate the exact best fit line, which your calculator will do for you. Okay, so here's how we enter data into your calculator. We are going to enter into the calculator this table I made right here. And we're going to let the calculator get the best fit line for us. So you start by hitting stat. Stat is right at the kind of the top middle area of your calculator. It's right here is the stat button. You're going to want to hit stat and then hit enter. And you will see a table, a bunch of L1s, L2, L3, right? You see this table, hopefully. And in the L1 column, we're going to enter the x values. So my x values were 0, enter, 2, enter, 5, enter, 7, enter, 12, enter. And I have entered all my x values in the first column. Then I'm going to use the arrows and go over to the second column and enter those values. So 0 was 44, and then I use the arrow to go down, or I could just hit enter. And then I have 41.1, and then I have 39.8, and then I have 38.8, and then I have 34.1. And I have entered all of the table into the calculator. All right, so now the calculator has the data in it. And part B, I can find the best fit line. All right, I am right here. So now I'm going to find the best fit line. So I'm going to go back and hit Stat. And then I'm going to use the arrows, and I'm going to arrow over. See at the top of the screen it says Calc? I'm going to use the arrows to go over and highlight Calc. And then I'm going to hit 4 for option 4. I'm just going to hit the 4. And a bunch of stuff comes up. And at this point, you can just keep hitting Enter 5 times, or you can arrow down to calculate and hit Enter. So after I hit Enter a bunch of times, I get this. Now, don't worry about the R and the R squared at the bottom. I'll show you that in a second. You might not have that. But what you have is, you have this y equals ax plus b, which ought to look like slope-intercept form to you. It is. And they have told you what a is. A equals 0.8 if I round it to 1/10. And they're telling me that B equals 43.5. So what that means is, and I like to round I know these numbers are long decimals, I like to round them to the nearest tenth. That tells me that the equation for my best fit line is y equals, it's negative 0.8. I didn't catch the negative there on the slope. Negative 0.8x plus 43.5. And if you look back at the equation that I calculated using my best fit line, pretty close. I have negative 0.9 instead of 0.8, and I have 43.9, they have 43.5. So we did a pretty good job of calculating the best fit line. Well, there you go. You have just learned how the calculator will calculate the best fit line for you. Now, I need to say something about the R value. If you want your calculator to give you the R value, you have to go to the second button and then the 0. At the bottom of your calculator, above your 0, it says catalog. Stay with me on this now. So you hit second and catalog, and you get a catalog of everything in the calculator. And you need to scroll down until you get to diagnostics, which they're in alphabetical order. So you go down until you get to the D's, and where it says diagnostics on. And there, I kind of have it on my screen there in the middle, diagnostics on. So I highlight that when I get to diagnostics on, I hit enter, and I hit enter again, and it has turned the diagnostics on. Now, if you go back and find the equation for the best fit line again, it will give you the R value. And what was the R value? I have forgotten already. Let me go back and calculate it again. Look at my R value. My R value is like 0.985. The R value is like 0.985 or something like that. That is really strong. Remember, that's going to be, you want that as close to 1 as possible. I mean, the closer to 1 it is, the stronger the relationship. So this means there is a very strong relationship between, actually, it's negative. I keep forgetting the negative, don't I? It's negative 0.9 because my slope was negative. The closer to negative 1, the stronger the relationship. There is a very strong relationship between the number of minutes since I ran over the nail and the tire pressure in my tire. And that makes sense, doesn't it? Okay, you can mess around with letter C. You can mess around with this, but it's really cool. I don't want to go through it. It's right there for you. It will actually let you see maybe I can show you mine. It will let you see the scatter plot and the line of best fit. Let me do it real fast. I'm going to hit second, y equals, then I'm going to hit enter, then I'm going to hit enter again, and then I'm going to go hit graph maybe and see what happens. Wait a minute, then I need to see the best fit line. So I have to hit y equals. Now I'm doing this, and then hit vars, and then let's see, slide over to hit pick option 5, go over to EQ, and hit enter. And then I'm going to hit the graph and see what happens. Oh, that's right. Nothing happened. There's nothing on the graph. Why not? Well, sadly, because all the data is not in view of my screen. Because the data is up around, up in the y equals 30 to 40 range, and my y-axis only goes up to 10 on the standard screen. So, to fix that, I can hit the window button. There's a window button in the top row of your buttons. And if I go to X max and I make the maximum 50, and then I hit graph, let's see what happens. Uh-oh, still not good enough for me. Well, I'm running out of time on the video here. You can mess around with those buttons that I've shown you now. And I'm going to skip. I've already gone like 31 minutes. So I'm going to skip the last thing. I will do it in another video, or we'll talk about it on Zoom. You've got enough to do the homework. Good luck. See ya.